Welcome back. In this lecture, we will discuss AWS Serverless Compute Service, which is called as Lambda. We will discuss what it is, how it works, and then we will have a short demo by executing a small code snippet using Lambda. Alright, let's get started. So, what is Lambda? It is a compute service that lets you run code without provisioning or managing servers. Also called as serverless compute, as you will not be managing any servers by yourself. AWS Lambda executes your code only when needed and scales automatically from a few requests per day to thousands per second. And with AWS Lambda, you can run code for virtually any type of application or backend service, all with zero maintenance and administration. AWS Lambda runs your code on a highly available compute infrastructure and performs all of the administration of the compute resources, including server and operating system maintenance, capacity provisioning and automatic scaling, code monitoring and logging. All you need to do is write your logic in Lambda supported languages. Below are currently supported by Lambda, which are Java, Python, C# or .NET, Go and Node.js. Alright, let's take a look how it works. When building an application on AWS Lambda, including serverless applications, the core components are Lambda functions and event sources. An event source is the AWS service such as S3 or DynamoDB table or SNS or Kinesis stream or even the CloudWatch scheduler or any of the custom application that publishes events. And a Lambda function is the custom code that processes these events. So we will first create a Lambda function and write our logic according to our event source. We then set up this Lambda function as a trigger for any of these event sources. So when an event occurs, let's say in S3, when an object is created, it will trigger the Lambda function by sending the event information as an input, like the object key, size, metadata, creation time, etc. So once Lambda function is triggered, AWS will launch the compute and manages its operating system, its scaling requirement, etc. and then runs your code. If your code in turn has to call any downstream systems, let's say S3 or EC2 or any other AWS service, it will be done via IAM role you assign to run the Lambda function. So appropriate access policies must be assigned to the IAM role in order to call the service on behalf of your Lambda function. And whatever logging you write in the code will be sent to CloudWatch logs using IAM role, and the role must have privileges to create CloudWatch log stream, put logs, etc. So the main advantage of doing this is that you can trigger thousands of Lambda functions at once without worrying about the scaling infrastructure. AWS will automatically provision the infrastructure for you. All you need to worry about is your code and its logic. However, there are certain limitations. Maximum memory you can allocate to a single Lambda function is 3 GB, and the maximum time a Lambda function can run is 15 minutes as of today. So if you have any memory intensive or long running applications, Lambda may not be the right fit. AWS Lambda manages the compute fleet that offers a balance of memory, CPU, network and other resources. Now this is in exchange for flexibility, which means you cannot log into the compute instances or customize the operating system or language runtime. If you need to manage your own compute resources, AWS offers other compute services to meet your needs such as EC2, ECS, Beanstalk, etc. You can also run Lambda functions within a VPC, so whatever code you write will follow the network and security rules configured for your VPC. However, as Lambda function automatically scales based on the number of events it processes, you must make sure that your VPC has sufficient elastic network interface capacity to support the scale requirements of your Lambda function. You can use the following formula to approximately determine the elastic network interface requirements, which is projected peak concurrent execution into the memory you allocated by the maximum memory, which is 3 GB. If your VPC does not have the sufficient elastic network interfaces or subnet IPs, your Lambda function will not scale as requests increase, and you will see an increase in invocation errors. Let's take a look at some of the typical scenarios of using Lambda. So the first one is real-time file processing. You can use Amazon S3 to trigger AWS Lambda to process data immediately after an upload. For example, you can use Lambda to calculate checksum hash of a file uploaded and then add it to metadata to the file in S3. And then real-time stream processing. You can use AWS Lambda and Amazon Kinesis to process real-time streaming data such as website clicks or financial transactions or social media feeds or IT logs, etc. And then Lambda is triggered and you can insert the data into DynamoDB, then your end users can access your data. And you can also use Lambda as an ETL solution, which is extract, transform and load. You can use Lambda to perform data validations or filtering or sorting or other transformations for every data change in a DynamoDB table, and load the transform data to another data store such as Redshift. And then you can perform your analytics using tools such as Tableau, ClickView, etc. By combining AWS Lambda with other AWS services, developers can build powerful web applications that automatically scale up and down and run in a highly available configuration across multiple data centers, and with backups and with multi-data center redundancy, etc. In short, you can make your web application serverless without you need to manage any of the compute resources or worry about the high availability. You can put your front-end codes such as your HTML, JavaScript, CSS, etc. into an S3 bucket, and you can make API requests from your front-end code to API gateway, from where you can trigger the Lambda function, and the Lambda function in turn put the data into and from the DynamoDB table. Alright, enough of theory. So let's get on to AWS console and see how we can create Lambda function and how it gets executed. Okay, I'm on AWS console. In this exercise, we will perform a simple real-time file processing event through Lambda. I have created 2 buckets in North California region, and this exercise would copy whatever files we upload into the source bucket to the destination bucket. Alright, before we jump onto Lambda function, we first need to create an IAM role with appropriate privileges to access the bucket and write the logs to CloudWatch. Alright, let's search for IAM in here, and let's click on roles and click on create role. Let's choose Lambda as a service, and let's create a policy to grant permissions. Click on create policy, and we will use JSON, and we will copy this JSON file. This policy grants read access on source bucket and put object access on destination bucket. Along with that, this also grants CloudWatch logs action to perform logging. Alright, let's paste this on the console, and then let's give it a name and click on create policy. Let's go back to the role and refresh. We should find our new policy in here, and there it is. Let's select it and click on next. You can add tags, but we will ignore it for now. Click on review, and then give the role a name and click on create role. Alright, the role has been created. Now let's go ahead and create a Lambda function. You see this screen when you're visiting the Lambda for the first time. So let's click on create function. Let's give it a name, and here you can select the runtime, the language in which you would like to write your Lambda function. Let's choose Python, and then you can choose an existing role, or you can create a new one from here. Let's choose an existing role which we created moments before, and let's click on create function. And here you can manage your Lambda function and its configuration. You can see Lambda function is triggering CloudWatch logs and S3. They were detected from the policy we attached to the role we are using to run this function. And when you add this function as a trigger, you will see the service on the left section in here. So if you click on monitoring section in here, you can see the metrics from CloudWatch, such as number of function invocations, durations that this function has run, etc. And with these metrics, you can create a CloudWatch dashboard so that you can monitor your Lambda functions, or you can set an alarm to be notified when they exceed a specific threshold. So let's go back, and you can write your code in line here, or you can write your code or create a zip file and then upload a zip file in here, or you can save your code in S3 and serve it up from there. You can also choose a runtime from here, and the handler in here dictates which function to be called. Suppose in here lambda underscore function is the Python file, and the lambda handler is a function inside that file. And this function should take two parameters. The first one is the event object, which contains data regarding the triggering event, such as S3 object information or a Kinesis stream, etc. And the context object contains the context of this running function, such as a log context, duration left for this lambda function, etc. And I have a function ready which performs the copy of an object to destination S3 bucket. So let's copy this function and then paste it in here. And here you can add environment variables as key value pairs to store configurations such as bucket names or usernames, database ports, etc. So let's add our destination bucket configuration as an environment variable. And here you can allocate the memory for your function. As you can see, the maximum is 3 GB as of today, and this might change in future. And in here you can set the execution time, and the maximum is 15 minutes as of today. It has recently been changed from 5 minutes to 15 minutes, and this might also change in future. And you can change the role of the Lambda function from here if you would like to. And as discussed in our presentation, you can also run the Lambda in a VPC. You can choose the VPC from here, and then you can choose the subnets in which the Lambda function to be run. AWS recommends to choose at least 2 subnets from 2 different availability zones in order to keep your Lambda functions be highly available and fault tolerant. If you would like to access internet from the Lambda function, you must associate a NAT gateway or an internet gateway to the subnets. You also need to choose the security group which controls the security for the Lambda function. Let's run this in no VPC for now, and when you run in no VPC mode, AWS manages the Elastic Network Interface IP address allocation, and you can by default access internet from the Lambda function. Any Lambda function invoked asynchronously is retried twice before the event is discarded. If the retries fail and you're unsure why, use dead letter queues in here to direct unprocessed events to an Amazon SQS queue or an Amazon SNS topic to analyze the failure. And then you can probably retrigger the Lambda function from your SNS and SQS by passing this event. If no DLQ is configured, the event would be discarded. By default, AWS Lambda limits the total concurrent executions across all functions within a given region to 1000. And by default, the concurrent execution limit is enforced against the sum of the concurrent executions of all the functions. The shared concurrent execution pool is referred to as the unreserved concurrency allocation, and if you haven't set up any function level concurrency limit, then the unreserved concurrency limit is the same as the account level concurrency limit. and in here the default is the account level concurrency limit, and if you would like, you can also set up your own reserved limit for your function. And if you scroll up under actions, you can publish a version, and when you publish a version, Lambda makes a snapshot copy of the function code and configuration in the latest version. The published version is immutable, which means the code and configuration cannot be changed once you publish. So each version has its own unique ARN, and you can invoke a specific version if need be. You can create one or more aliases for your Lambda function, and Lambda alias is like pointing to a specific Lambda function version. By using aliases, you can access the Lambda function as alias is pointing to without the caller having to know the specific version the alias is pointing to. This gives flexibility for you to publish and release the versions as you want, and the caller doesn't need to change the version ARN every time you publish a new version. And you can delete and export the functions from here. You can also test your function from here, and you can create a mock test event from here, and you can give your JSON data just like an event like S3 object, etc. And then when you click on test in here, it is going to be passed as an event to your Lambda function. Alright, let's save the function and add it as a trigger for S3. Let's go back to S3 and click on the source bucket, go to the properties and then to the events, and let's add a new event. Let's give it a name, and then you can choose the event which will trigger a Lambda function. Let's choose all objects create event for now, and you can add a prefix and or a suffix. Then let's choose the Lambda function which we created, and let's save it. Now let's add a small file to the source bucket. Now go ahead and select the file and click on upload. Alright, the file has been uploaded. Now let's go back to the destination bucket and let's see if the file has been copied. And there it is. The event triggered Lambda function which copied the file to the destination bucket. Simple. So let's see how to check logs for the Lambda function for you to monitor. Let's go back to Lambda and go to our function and click on monitoring in here, and you can navigate to CloudWatch logs from here. Now this will take you to the specific Lambda functions log group, and from here you can see all the log groups in CloudWatch logs. So each Lambda function will have its own log group, and now if you go into this log group of our Lambda function, you will find the logs pertaining to this function. So if you click on this log, you will see the information whatever I have logged in the Lambda function code. So that's about how Lambda works. It is a very powerful service provided by AWS which can be used by all different scenarios wherein you would need to execute your application logics without thinking about managing a fleet of compute resources. That is it for this lecture. Hope you have enjoyed this lecture. Join me in the next lecture. Thank you.
For more details, check the link in the description. Learn with Whizlabs. Success certified.